Okay, Unit 1, Lesson 1, Page 2. Students will be able to reduce and evaluate rational expressions as well as identify values for which rational expressions are undefined. Undefined. Let's see. You can have no 7s. In fact, you can put that in your calculator. 0 divided by 7 will give you 0, okay? But your calculator doesn't know how to handle this. It doesn't really exist. 7 divided by 0, your calculator say error. Mom system says does not exist. So rational expressions are algebraic expressions that are written as a quotient of two polynomials. There's one and there's one. It just basically means there's variables involved. Notice there's still a division sign right there, right? So that's called a rational expression. And Q, this is kind of a representation of a rational expression, Q can't be 0. So you can't put anything in for B. Let's say you put in a 0 for B. That'll be 7 times 0 times whatever C is. That makes it this undefined because 0 would be on the bottom. Okay, so you can't do that. So when you're working with rational expressions, to be able to say them, it says when solving, set each denominator to equal to 0 and solve for the variable. Okay? So in other words, here, remember, that's your numerator, that's your denominator. So x plus 5 in this case, set it to equal to 0 and solve for the variable. So move the 5 to the other side by adding its opposite. X equals -5. Okay, so that means for this rational expression, x can't equal -5 because it would make it undefined. All right, so that's the number for which it would be undefined. All right, what about this one? Here's your entire denominator, set it to equal to 0. Well, to solve for x for a quadratic, you have to factor. There's a negative and then a positive, which means there are 2 negatives. The factors of 2 are 2 and 1. Set each factor equal to 0 and solve for x. So x can't equal 1 or 2 for that rational expression, okay? Set your denominator equal to 0. This is a 2-term factoring, perfect squares, root, positive, negative. So that's how you would factor that 2-term. Set each factor to equal to 0. Solve for your variable. So n in this case can't be 4 or -4. That would make them undefined expressions. Okay. D. Excuse me. Excuse me. Pardon me. All right. It costs television manufacturer this many dollars per television to produce so many televisions. Right? X is the number of televisions. Discuss why it makes sense for the cost per television to be set undefined for the value of x if x equals 0. So in other words, if you're not making any televisions, if x is the number of televisions and it's 0, that would make this expression undefined. And it doesn't matter because you wouldn't be talking about a cost per television if you weren't making any televisions. Okay, but if you decided you were making like 1,000 televisions, you would put the 1,000 in for the x, and it would tell you your cost per television if you were making 1,000. Okay, so I'm assuming the 10,000 is kind of startup costs, and the 95 is per unit materials or something like that. Okay. Skill 2 says, evaluate rational expressions. Evaluate rational expressions by substituting values in and using orders of operation. Please show your work. You will get credit for substituting correctly. So for this rational expression, it says put in a 6 everywhere there's an x. So 6 squared minus 4. Yes, I use parentheses. It's a good habit. to get into. All right, step 1, substitute. Step 2, use order of our operations. 6 times 6 is 36. Right, 2 6's times each other is 36. 36 again. 32. What's this one? This is going to be 80. Reduce, I believe 16 goes in them both. That's going to give you 2/5. Okay. This is why you need the parentheses. It's very important. Oop. Okay. Just for clarification, if you have -6 squared, is that the same as that? It's probably one of the most common mistakes in algebra people can make. This is a -1 times 6 times 6. This is a -6 times -6. This is going to equal a positive 36. This is going to equal a negative 36. So they are not the same. Okay? So these parentheses aren't really necessary. These really are. Okay? So just make sure you're being careful with those. All right, -6 times -6 is still a positive 36. All right, but right here, this rational expression turns different than the first one. A positive 6 times a -6 is a negative 36. All right, so this is 32. Those kind of go away. That's an 8, so that's a 4. All right. All right, -1. Oops. Oh, my goodness. Can't do it. Hang on. Okay, step 1, make sure you write it correctly. Substituting correctly is very important. All right, -1 times -1 is a positive 1. -5 times a -1 is a positive 5 plus 4. -1 minus 1. -1 minus 1. That's a -2. All right. On top, that adds up to a 10. Negative 10 divided by a -2. This is a good. That's a good. So you can use your calculator in some of these places. Just make sure you're showing your work as you go. Okay, it keeps it nice and neat and straight. All right, next page. Page 3, we're going to reduce rational expressions. All right, that's a rational expression that needs to be reduced. We need to reduce the numerical coefficients like you would any other. So 21 by 18. Divisibility rules say that 3 goes into both of those. That one, 3 goes in 7 times, 3 goes in 6 times. So I know there's going to be a 7 and a 6 going on. And then notice that I have x squared on top minus 6, because when you reduce exponents, you're subtracting the exponents. So the numerator is exponent minus the denominators. This bar, division bar, is like a subtraction to exponents. So you're going to get a -4. You cannot put, you need positive exponents only in your answers. Okay? So how do we make this positive? You put it underneath. And that makes sense. If there's 6 on the bottom and 2 on top and you reduce that, that means there's 4 left over on the bottom. Okay? Let's see, 20 over 40, divided by 10, and then divided by 2, you're going to get 1/2. And then there's an A here. Doesn't have another A, so I'm going to put that in. And then B's, the B, there's a 1 here when it doesn't say. So 1 minus 5 is B to the -4, which means the B to the 4 is down there. And make sure you put this 1 on the numerator. You know, a half isn't the same as 2, so don't bring the stuff in the numerator up if there's nothing up there. You have to hold it down there with a 1. okay? Let's see, 15 and 25. 5 is a 3, 5 is a 5, 3 and 5. And then the x's, there's an extra 2 on top, and an extra 4 on the bottom, but let's check. 4 minus 2 is x to the 2. Yep, goes on top, because it's positive. Y to the second minus 6 is y to the negative 4, goes on the bottom, because it's negative. Okay? All right, what if we have more going on? Polynomials. That means there are more than one term, and you have positive, a plus sign and addition and subtraction between them. Okay? I think this is important to note right here. See, this 15x minus 5 is an expression with two factors. There's a 5, right? You can take out the greatest common factor of a 5, and what's left is 3x minus 1. That's a factor, and that's a factor. Those are the two factors. You cannot, like, cross out anything inside that factor. You'd have to cross out the whole thing. So let's look at that. So first thing you have to do is factor anything. Greatest common factor for this one would be 8. And after you take an 8 out, you have a 2. There's not much you can do with that, but you can take an 8 out of the 28 and get a 7. So this is going to reduce to 7 over 2 times x squared minus 2. And you don't have to put them back together, just leave them like that. Okay? Did you follow that? I took the greatest common factor out and reduced it from the top. If you had a 28 over 8 and you divide it by 4, you get the 7 and you get the 2. Okay? Take out greatest common factors wherever you find them. Negative 3, 3x plus 1 comes out of the top. Took out the negative because I'm hoping it's going to match something on the bottom. So I took the negative out, so the signs would be a plus. Okay, take a 6 out of the bottom. That will get me something that matches. That goes away, and then you're going to reduce the negative 3 over 6 to negative 1/2. Okay. Sometimes you can do more, like if this was factoring, but there's no reason to because there's nothing on top to reduce it by. All right, this is a two-term factoring, perfect square, plus and a minus, and then the root of 25 is 5. These are both pluses, so my answer has 2 pluses. Factors of 15 are 3 and 5, so it doesn't matter where they go. That reduces down. This will be x minus 5 over x plus 3. Right? So when you have a polynomial, make sure you're factoring. Take out a greatest common factor, and then factor, or just factor to start with, but reduce them to factors so you can reduce them away. Okay? Greatest common factor can be variables. Ooh, this one's tricky. I took out an x. That left me a perfect square minus a perfect square. So that means it factors some more. Plus and minus, or minus plus, doesn't matter the order. All right, so that comes out. That comes out. I should be changing the color of the pen, shouldn't I? Hang on. So that leaves here, let's write up here, 4 on top and x plus 5 on the bottom. All right. All right, and then a few more to practice. All right, let's see, a couple to evaluate. I'm going to put in a negative 4. Let me go this way with this one. All right, negative 4 times a negative 4, 16. Positive 7 times a negative 4 is a negative 28, plus 10. 10 And negative 4 plus 2 is a negative 2. That comes out to negative 2 over negative 2, which is a 1, right? Same thing over the same thing is 1. Put it in your calculator if you're not sure. Negative 2 divided by negative 2 is a 1, okay? This one over here is a negative 2. Show your work. All right, let's see. Negative 2 minus 2 is 4. Minus 4 minus 8. Try not to do too many things at once. I think that's where people have a problem. All right, all of this stuff is a negative 8 over 2. Negative 8 over 2 is a negative 4. Okay. All right, and reduce. All right, this one, 56. And 16, 8 goes into that twice. Divided by 8 is twice, and divided by 8 is 7. So that's going to be a 2 over 7. And then we have, oh, they're trying to be tricky. Look at the y's. The y's, if you have y squared over y squared, that equals 1. So the y's disappear in your answer. And then you have W4 minus 2 is W2. So that means there's extra. This is positive, so that goes on top. Or notice that there's 4 on top, 2 underneath. And when we reduce them, you're going to obviously be left over with 2 on top. So that's your answer for that one. Factor. All right, with 2 negatives mean you're going to have 1 positive, 1 negative. Doesn't matter which one. Factors of 12 that are 1 apart is how I think of that. Think of 12. You have 1 and 12, 2 and 6, 3 and 4. These are 1 apart. I need that 1 right here for my B. So if I make, and it's a negative 1 too, so that means if I make negative 4, make the 4 negative and the positive, that'll be in the right order. And then I can take these out, which means 1 over x minus 4. All right, factor x, plus a plus in the problem is plus and plus in the answer. Factors of 8 are 1 and 8, 2 and 4. 2 and 4 will get me a 6. 2 and 4 will get me a 6. Factors of a perfect square minus a perfect square, root, and opposite signs. That makes that one go away. So that's going to be x plus 4 over x minus 2. You cannot reduce these. Remember, these are factors. So you can't just kind of cross them out like that, okay? Sorry, excuse me. I have this cold for posterity in my videos here. All right. Reduce the following. Don't forget to check for GCF. All right, this one has a plus and a minus, so that means plus and minus. 56. Factors of 56 that are only 1 apart would be 7 and 8. The 8 has to be positive and the 7 negative, so when you subtract them, you get a positive 1. Okay, and that also works nicely with that. So your final answer is 3 over x minus 7. See how we have to know how to factor plus, 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 plus. 5 and 3. Plus, plus. Factors of 40. Factors of 40. 1 and 40. 2 and 20. 3 doesn't go in. 4 and 10. 5 and 8. What was I doing? I'm looking for 13. Oop, there's 13 right there. 5 and 8. There we go. Oh, and I probably knew it was 5. Take a hint from what was above. So my final answer is 3 over x plus 8. All right. Common factor would be 4x, x plus 3. Take out an x and you're left with x squared minus 9, which is a perfect square minus a perfect square. Root plus minus. That means that goes away, that x goes away, so I'm left with 4 on top and x minus 3. Minus 3 or plus 3? Minus 3. Okay, minus 3. Let me check my key on that. Sorry, give me just a second, and I'll fix that. I apologize. Hang on. If I don't do it now, I won't remember. Minus 3. Gotcha. All right. And then the last one. All right. That was a little harder to factor, but it's a prime. So that means it has to be 3x and x. All right. And a plus and a plus. And then factors of 2 is just a 1 and a 2. Is it going to matter if I put the 2 first and then the 1, or the 1 and then the 2? So there's only 2 choices. So you have to guess and check that one. So 3x plus 2 would make that 5. But 3x, so I think it's a 1 here and a 2 here. So let's check that. That would be, outside would be 3x squared. But then inside would be 3x times 2 is 6. Plus 1x is 7. And that's 2. So that's correct. This one is a perfect square minus a perfect square. Don't forget 1 is a perfect square. So 3x plus 1, 3x minus 1. So these go away. So your final answer is x plus 2 over 3x minus 1. And I think that was the last page. Well done. Thanks.